So, firstly, a little bit about Crew. Who are we? Well, we are a community energy group that has been working away mostly in southwest London since our first project was completed in 2017, not 7. We work with both organisations in the community, such as charities, local authorities and schools, to install technical solutions around solar, ground source heat pumps, heat transfer solutions, building management system technology. And we also tackle things like fuel poverty and informing people about action they can take within the climate emergency to reduce their personal carbon footprints. And we even go into schools sometimes with some education materials to help engage the next generations coming up about energy and how they can use it more effectively and what we can do to all do our bit. So without further ado, before I hand you over to Toby, we will be having a presentation for about 40 to 45 minutes from Toby. But what we'd like to know from you before is, what is your biggest concern or your most pressing issue that you would like to know about around heat pumps? And if you see in the bottom right hand corner of your screen, or depending on if you're using a phone or a tablet, you'll see a little symbol somewhere, if you're not too familiar with Google Meet, which will have a triangle, a square and a circle on it. And when you click onto that, you'll be presented with 3 little tabs of either, what are they? There's polls, breakout rooms, chat, Q&A, and that sort of thing. And you can see the poll there that has been launched. So if you'd like to type in an answer of, oh, Roger's cut off the start there, brilliant. We've got our first comment, fantastic. So just knowing the science of what you need to know about regards to a heat pump, and when you're looking at them for an install, that's a jolly good question. Let's start with the basics. Also, that will give us an idea to try and make sure that we highlight particular elements regarding the session. So we'll curate those comments as we go through. And also, if you have any particular questions, if you want to pop them in the chat, then what I will do, whilst Toby's leading the presentation, I'll kind of corral them all together, and we can put them to Toby to extra earn his money this evening when he finishes off. So do ask questions as we go along in the chat, and I will try and answer the more beginner or intermediate level ones, and we'll leave the more complicated ones for Toby to answer. So without further ado, if you want to just pop your point in the chat rather than changing the poll, I think that would probably be the easiest. So without further ado, I'd like to hand over to Chair of Crew Energy, Voluntary Director, Master of Heat Pumps, Toby Costin.
Evening, everybody. Thank you for that rather grand introduction. So the poll, if we have a quick look at that so far, we have a couple of people sort of saying other, but it looks like upfront costs has got 10 votes, lack of knowledge 2 votes, running costs 2, where to put it 3. So at the moment, it looks like the upfront cost is the biggest issue, which is perhaps unsurprising, but polls are shifting all the time. So please vote. It'd be really good to get everyone's opinion on this, just so we know the best bits to address it in the presentation, really. Right. Let me see if I can now jump slides. So can you all see the new slide? Why renewable heat? Yep. Great.
Yes.
So
yeah.
So why are we all getting worked up about this? I think that sort of the most interesting thing was probably last week. I think it was the IA came out and said, let's stop selling gas boilers from 2025. I mean, that's an incredibly short runway, and probably even they knew was impossible to do, but maybe it makes people think. Interestingly, the UK government came out a day later and said, well, we're going to try and do it by 2035. Then a week later said 2033. So it's had an impact. You know, it shifted this government 2 years, which is a great start. Also remember that way back in Philip Hammond's days, and we've been trying to remember Hammond's first name, we kept coming up Richard Hammond, but Philip Hammond was Chancellor, brought in a law that any new builds, any new gas grid connections will be banned in 2025. Now, I think there's about 3 or 4 councils in London that have already said, from now, you know, no more new gas grid connections. So the world is changing, and it's a bit like EV cars. You know, this thing is changing faster than we realise. You know, a couple of years ago, everyone was talking about, well, when EV cars. Now we're hearing things like Volvo will only produce EV cars by 2025 in Europe. No other types of cars. So I think we're about to see that sort of acceleration and that catalytic reaction in this sector as well. We know that UK government set a target to install 600,000 heat pumps a year by 2028, which is incredibly ambitious, and maybe there isn't the framework to support that. And we'll discuss a little bit of that as well in this. So it's going to kind of give you a broad view. Now, obviously, there's 2 big bits here: carbon emissions and air quality. And the carbon emissions is probably the most stark thing, and I think it shocks us all when we actually see this stat for the first time. But you know, your typical gas central heating system will pump out around about 2.8 tons of carbon if you're consuming 15,000 kilowatt hours a year. That's a lot. You know, when the average person's footprint is somewhere between 10 and 12 kgs, you know, your gas boiler is a big chunk. Then we're really having a big impact. Switching to heat pump can bring that down to below a ton, and if you're on a green tariff and you're pumping green power into your heat pump, then obviously we're getting closer to 0. You'll be around about 0.1, and that reflects things like you need energy start up a wind turbine, your solar PV needs an inverter that uses electricity. So you know there are costs to this generation. The other bit as well to think about when you with gas central heating is the gas flow emissions, and we've been doing some work on this, and I don't know if people know, but what typically comes out of particulate matter, which is a really big factor in London with air quality, carbon monoxide, and nitrous oxides, which is the other really big thing for air quality in London. And what we're seeing is that actually, if you take London's homes and London's businesses, their gas boilers contribute 1/5 of all the NOx emissions. So I'm on lots of forums, and people are always sort of banging the drum saying, we've got to stop all these cars, we've got to stop these buses. Actually, no one's talking about stopping their own gas boilers. So I think we need to kind of wake up to the fact that this is a really big factor, both on carbon and on air quality. So what we're going to try and do is a bit of myth busting first, because I'm hoping that this audience probably knows something about heat pumps, but just wants lots of questions answered. So we're not going to start at the very beginning here. We will go to the beginning, but I think this might be a little bit more interesting to start here. So the first thing is, why don't we just wait for hydrogen? And I have reservations on a number of levels. I think one is hydrogen has very different shades. There's grey, where it's made straight out of cracking gas, and that's horrible and dirty. Then there's blue, where you do that, but you pump all the carbon emissions into the ground. That's called blue. Don't really like that either. And then there's green, and green's fine. I mean, it still creates some emissions, but it's okay. The issue with it is it's incredibly expensive, and Wood Mackenzie reckon that hydrogen will reach gas prices, green hydrogen, by 2040. So there is this sort of constant push by the lobby to say hydrogen is going to be a solution for everything. It isn't. It might be the solution on very large scale industrial processes, but it's probably not going to be a solution for us in our homes. The other thing about this is it needs an enormous amount of energy to produce hydrogen. You know, so these electrolyzers are 70% efficient. So for every kilowatt you produce or you consume of electricity, you're only getting 0.7 kilowatts of hydrogen. That's a pretty expensive process, and we need an enormous amount of electricity. When you think that 20% of our energy consumption in our homes is electricity and 80% is gas, we would need 5.7 times the amount of generation we have today to produce the hydrogen. So it's clearly not the answer. Heat pumps are expensive. So look, the upfront cost compared with gas boiler, yes, it is. The great thing is, until the end of next year, there is subsidy. It's called the RHI, and we will talk about that in more depth in future slides. We're also going to see a improving efficiency of heat pumps, and that's already happening. I mean, if you look at the sort of government current regulations, they're assuming that heat pumps are 250% efficient, and they're 350, 400% efficient now. So regs are way behind where the market is in terms of efficiency. And in terms of cost, Octopus came out, I think just last week actually, and said they thought that we might see a 40% reduction in prices over the next 18 months. I'm not sure they can achieve that. I reckon they might achieve that over 3 or 4 years, but probably not 18 months. Heat pumps are expensive to run compared with gas central heating. Again, we're going to show you standard numbers and show you what the running costs of the two things are. And that obviously was part of the poll, and some people, I think 3 or 4 people said it's the running cost that I'm concerned about. Heat pumps are a new technology. Well, they're not. I mean, if you think about your fridge, it's the same thing, right? It's a compressor with refrigerant in it, and you've had that for decades and decades and decades. Heat pumps have been around for decades too, so they're not new technology. The other one is that they're big, ugly, grey boxes. Well, that's increasingly changing, as we can see from one relatively lovely model and one super sexy model in these pictures. So manufacturers kind of getting the idea that people don't want a big grey box that looks like an air conditioning stuck outside their house. So they are improving the look, decreasing the size, making them quieter as well. And on the quietness side, and I know this is consideration for some people. So if we start with the sort of background stats, London background noise is 41 decibels. Whisper quiet is 31. If we take, say, an 8 kilowatt heat pump in the middle here, and this is NEBI data for NEBI's 2040 heat pump I've used here, it would be 54 decibels if you were standing on top of it, 2 meters away, and you've got to be a certain distance away from your boundary for planning permission, which we'll cover as well. It's only 40 decibels. You're below London background noise. And if you're 6 meters away, which is probably where your neighbors might be, or even you might be, it's 30 and a half. You're down to around about whisper quiet. So they're not that noisy as soon as you're away from them. And they're not even that noisy when you're next to them, to be honest. I mean, 54 decibels isn't too bad. And obviously think about the fact that these things are running typically when you're cold, so your windows are shut. So you're probably not going to hear them at all. So I've hopefully busted a few myths and things that people have been concerned about. So why has there not been this rollout then, if I can answer those questions so easily? And I think there's several factors here. One is the lack of cohesive government strategy. So they kind of have jumped around a lot on this stuff. The second is the power of the gas lobby. So we've just had a white paper put out at the beginning of this year suggesting what will replace RHI. The input on that, BEIS took 144 meetings from fossil fuel companies and 5 meetings from renewables companies. So you can see why the big push for hydrogen now, and there's currently a 5-year government pause on policy to see if hydrogen can catch up. And that's because of the Cadence of this world, who supply all the major pipelines to areas, and then SGN, who supply the pipelines to our houses. You know, it's big business, and without gas, they don't really have a business anymore. So there is a huge amount of power there pushing to try and keep the gas industry alive. Then we've got, I think, a really big factor has been the flux in the renewable energy subsidies. So we had RHI, which was due to finish last year. The government then realised they didn't have time to get a new policy in place, so they extended it a year for domestics, but not for commercials. And if you think about a block of flats, that's considered commercial because it's more than one property. So we're now in a situation where you've got people who might have a shared freehold, so the 50 people in a block of flats, and they've got a shared freehold. They're not entitled to RHI, but someone in the house is entitled to RHI. That's inequitable. And the government's kind of left themselves in this bit of a limbo for this year. And it looks like they might make the same mistake with what's replacing next year. The other thing is what replaces next year is only at the moment around for 2 years. So we've constantly got installers and manufacturers, wholesalers sort of saying, I'm not sure about UK's commitment to heat pumps. So I'm not going to invest in training people. I'm not going to invest in plants here. I'm not going to invest in stock warehousing here because it's not a long enough signal for me. And I think what that's done is created a lack of industry skills, knowledge. And because you don't have that, and because people aren't invested in and say, right, I'm in this for the next 10 years, you've got lots of people coming and saying, well, I'll make some money for 2 years and then I'm gone. They're not going to invest in the education programs, the advertising campaigns to make people realize what these products are and how well they can work. So I think when you're worried about heat pumps, say, well, why is it not on anybody's agenda? I think these are the reasons why. Okay. So hopefully that gives a little bit of comfort why we think we are where we are, but things can change. I mean, what we need is a fairly stable policy for the next 4 or 5 years and enough financial support to make this work. So someone asked, I want to know the basics. How does a heat pump work? It works the same way as your fridge. If you pull your fridge out and fill the back, it'd be really, really hot. And all you're doing is just replacing where the heat exchanger is there. So in this scenario, we're looking at a ground source heat pump. So that's taking heat from the ground, which is a fairly consistent heat once you get a couple of meters below the ground. You bring that up and you kind of intensify that heat. So this is refrigerant running through the system, coming into the evaporator, and then that gets pressurized. And as it gets pressurized, it produces an enormous amount of heat. That's where the heat exchanger will then take that heat and supply it into your heating system. Okay, and then as you return, you're returning a flow back in, and then the whole system reverts around. So typically in a ground source system, that water's getting pumped back down again to be reheated. In an air source system, you've just got a closed loop, and it's just going across the heat exchanger. But that's essentially how they work. They work exactly the same way as the fridge. And you think about your fridge, how often you get repaired. This is the other big benefit of a heat pump over gas central heating is these things just run and run. I was talking to Clarion Housing, the largest housing association in the UK. They have 125,000 properties, and they've installed about 1,000 heat pumps because they've got a huge amount of properties in East Anglia where they're off the gas grid. And I just asked them, just out of interest, what are your running costs compared, or your O&M costs compared with your gas heaters? And they said, well, they're infinitely better. And I said, well, what do you mean by infinitely? He said, well, we've just installed them and they just run. We don't have a maintenance schedule for them. And this is, a big, serious housing association. So their view is they're pretty solid. They keep running. So I think within your economics and when you're looking at things, that is a really big thing to think about, is that these are just like your fridge. They're pretty solid. Yeah. And we'll see that in the warranties and stuff, which we can talk about as we talk about sort of some of the kit and things. So firstly, and I'm going to run through this fairly quickly because this is meant to be a fairly Southwest London target audience. And most of us don't have 2 acres of land, sadly. And if we did, it would probably be hemmed in by 6 other houses and you could never get drilling equipment in. But the great thing about ground source heat pumps is that consistency of temperature compared with an air source. You're dropping either horizontal loop systems like this or vertical boreholes deeper. The ones you can see in the picture there, they're around about 8 degrees. You would get a couple of meters down. If you go deeper, you get down to about 12 degrees. You're getting a better quality of heat. And again, it's a consistent sort of heat. Heat pumps are expensive when they're ground source, though. They can be about £20,000, if not more, depending on the size of your house. But at the moment, for this year, there is this renewable heat incentive. So you do have a subsidy that will really support payback over 6-7 years of that. As I said, in London, we don't have the space, right? So I don't think it's a big thing for this conversation. It might be for a few people. I think one of you said you're from Newbury. You might have a bit more space to consider. But even so, you need quite a lot of land. The other thing about it is, again, getting back to sort of being London-centric here, is you do require more space in your house because the heat pump is coming into your home. So rather than just having a hot water tank, you've got that plus the heat pump plus the buffer tank. So you need a bit more space as well than you would with an air source. So let's look at air source. Air source, clearly less upheaval. You're not digging up your garden, but you do have a placement consideration. And we've got a slide on placement. And I know 3 or 4 people in the poll, when I was looking at had made placement an issue. We've got lower cost. around about £10,000. You know, some might be cheaper, some might be more expensive. It's also the kit you choose. You can choose a fairly cheap sort of Korean heat pump that will probably last 10 years. You could choose a much more expensive Austrian unit that might last you 25, 30 years. So it's kind of swings and roundabouts really on that. Again, it's pretty well supported by the RHI at the moment, the subsidy. Not quite as well as ground source, but you should, in most circumstances, be able to cover your costs. The energy is derived from local air temperature, and this is one of the things where people go, well, I don't understand how you can produce 55 degrees of heat in my house when it's -2 outside. And that's just the science of it, right? We are using refrigerants that change state at -42. So to them, -2 is pretty warm. And also remember from GCSE science, or for lots of us O-level science, there is energy in heat all the way down to -272. It's only at that point is there no energy left in heat. All it means is the lower the temperature, the harder it is to extract that heat, and the harder the heat pump has to work. Okay, so your efficiency starts to fall once you start drop into the minus numbers, but you can still extract enough heat to make your heat pump run and be economic. I'd also want to talk about the two different types of air source heat pump. The one that we most often talk about is the monoblock, and lots of you will know the Mitsubishi EcoDam, for instance, being a sort of probably the biggest heat pump in the UK. But there are also split systems. So the monoblock has the fan, the compressor, all the gubbins in one unit outside the house, and it does all the processing there and then sends warm heat into the property. The split system leaves the fan outside and moves the compressor inside. So the fan is kind of dragging heat into it over and heating up the refrigerant. Then it goes through the compressor, and then the process starts in intensifying that heat. What are the benefits and downsides of both technologies? Well, clearly the monoblock's cheaper. That's what 10K. You can even expect to pay several £1,000s more, up to maybe double the amount for a split system. Why do you go for the split system then? Well, one is quietness. Because it's just the fan, you haven't got the compressor on the outside, it's a whole lot cheaper. This is based on, I think, the OCHSNER Eagle 414. A very nice looking system. 32 decibels is essentially whisper quiet. The other thing is they tend to be nicer looking units, and we'll see a couple of pictures in a minute. We can see that monoblocks are getting better looking. The one I showed you, the Valent, I think is a reasonably nice looking system. It's something that you wouldn't mind having in your back garden or at the front of your house, really, compared with the sort of big grey industrial boxes that maybe the Mitsubishi EcoDam looks like, which really should be hidden away on the roof somewhere. The other thing to consider is you've got more kit going inside your house, a bit like a ground source heat pump with the split system, because I've said heat pump here, sorry, that should say compressors coming inside as well as the water in the buffer tank. So you need a slightly more space for a split system inside. Now, the reason they're more expensive is the kit is more expensive, but also the engineer you need. You need a refrigerant engineer, and they're twice the cost of a normal heat pump engineer per day. So that really adds to the cost of the system. I think most people go for monoblock. Some people, if they don't care about the cost of things, they might be more tempted by the aesthetics of a split heat pump system. And here we are. This is sort of beauty and the beautier, I think. So the Valent's a really nice looking monoblock. And then you can see just the fan here running on the split system of the OCHSNER. The lovely thing about OCHSNER as well is they do this in 1,652 colours. So you can match your house, you can match your garden, you can match your roof, you can match wherever you want, really. Match your underpants. So yeah, it's a very nice looking system, but it is expensive. But you get what you pay for as well. Very good parts. Compressor warranty for 75,000 hours. Standard heat pumps are about 25,000 hours. So this thing will last you 30 years without thinking about it, really. Right. So some of you would have seen, if you've done a bit of research already, you might have seen things like the COP and the SPF, and you're wondering what the hell they are. So the coefficient of performance, we're really talking about if I put 1 kilowatt of electricity into a heat pump, how many kilowatts of heat do I get out, right? That's essentially what we're asking here. And COP is basically a static measurement, and SPF is a fluid measurement. So the COP says if it was 7 degrees every single day of the heating season and you kept your flow temperature at 45 degrees, your heat pump would be X% efficient. What the seasonal performance factor says is temperatures change throughout the season. So what is my efficiency over that season rather than just on a standard average performing day? Now, these factors are impacted by three things, really. Quality of the heat pump. So better quality heat pumps with better refrigerants, newer refrigerants, tend to have a higher efficiency rate. Obviously, if it's warmer outside, the heat pump has to work less hard to extract heat. It's two factors, really. One, it's starting at a higher temperature to get to its even higher temperature. And two, that whole extraction process is easier at higher temperatures. The second one is flow temperature. If I'm only asking my heat pump, because I've got underfloor heating, I only need to get to 35 degrees, then taking it from 7 or 8 degrees up to 35 isn't a huge jump. Taking it from 7 degrees up to 55 is a massive jump. So the flow temperature has a big impact on your efficiency. And just as a guide, I mean, living in Southwest London, where the bulk of us live in Victorian terraced housing built in 1900s, we're going to be running our systems at 55 degrees. If you're lucky enough to have a 70s build filled cavity wall, you probably get away with 45 degrees quite happily. And if you've got underfloor heating through your whole house, 35 degrees is your temperature. I've taken an OCHSNER 717 split system here, and these numbers are straight off MCS. So this is very much lab numbers. So 7 degrees constant temperature on a COP. We're looking at 440% efficient at 35 degrees down to 360% efficient at 55. That's still brilliant. I mean, one kilowatt in, 3.6 kilowatt out is a huge saving on carbon. It makes it competitive with gas, and we're kind of getting there on the economics of this stuff. So funding your heat pump, right? Hopefully most of you know there is a renewable heat incentive. It's paid over 7 years on a quarterly basis. And it's not based on what you consume. So you don't have a meter measuring how many kilowatt hours that you consume, like they did in Northern Ireland on the commercial system. On the domestic system in Britain, it's based on your deemed consumption, right? So you will need to have an up-to-date EPC to get the RHI. It's got to be within the last 2 years. If the recommendation that you need more loft insulation or you've got a cavity that needs to be filled, you will have to do those two measures before you can proceed to your heat pump. If you're in a solid build house and you've gone into your loft, there are no considerations, right? There's nothing you can do. You're just going to put a heat pump in. But what the government's trying to do is relatively small cost measures, try and do them. If it's a large cost measure like exterior wall that might cost £10,000 and pay back over 50 years, they're not going to force you into that. So on your EPC, round about page 3, there will be heating use in this property, and it will have space heating and water heating. Space is basically heating your home, your radiators pumping out heat, and obviously water heating is for your showers and your hot water. You add those two numbers together, and that's your deemed demand. And then how they work out the number is currently the tariff is 10.92 pence per kilowatt hour, but it's not on the whole amount of that, because what you got to remember is for every 3 or 4 kilowatts you're producing, you're actually using 1 kilowatt of electricity. So we made it a 4-to-1 efficiency heat pump, just the ease of maths. What that would mean is you get 3/4 of the combination of those two numbers, so 14,550. You'd get 3/4 of that as your deemed number, and you times that by 10.92, and that would give you how much you'll get in year 1. This is index linked over the next 6 years. So it's index linked to CPI, Consumer Price Index. So you'll get roughly 2% inflation on that year-on-year compounding. Roughly the maximum you'll get at sort of 400% efficient heat pump is around about £12,000. The most salient point on this entire slide is RHI ends in March 2022, right? And we drop to something much, much lower than 12,000, which we'll see in the subsequent slide. This is a very good window. And yes, prices will come off, but they won't come off at the rate the subsidy is about to come off. The other thing I would warn you is do not get involved in installing heat pumps in Feb and March in deep midwinter at the end of a period, right? We end up having to do this on our first commercial install this winter. Thankfully, I had already applied for an extension because we're a community group. We were granted that extension. You won't be granted extensions on a domestic basis. You will need all that document in place beforehand. What you'll find is your heat pump guys will delay because they've got too much work and they can't respond. There's very few installers in London anyway, and the southeast. It's a very short market. So when you get a crunch point like this, they are like gold dust. They will charge more the closer you get to that window. Kit will start to run out. Pipes will start to run out. You know, we had to wait 4 days for some valves to arrive, which would normally take a day. Now, this is partly COVID, it's partly Brexit, but it's also that crunch was coming, right? So do not do that. My advice to you would be, if you're going to go for this and you want to make the most of the RHI, get it installed over the summer. Again, you don't really want to have a house. Installs take 4 to 5 days. You don't want your house with no heating for 4 or 5 days. And with doors open with workmen coming in and out. So get it done while it's relatively warm still, and avoid that crunch. That would be my top tip, really, from this whole presentation. So what happens post RHI? At the moment, we don't know, but there's been a white paper and the government suggested £4,000. I think the industry said it's too big a step down. Could we talk about maybe 6,000? And if you think a new gas boiler is going to cost 2,000 to 3,000, heat pumps cost 10. Let's say everyone gets a bit more rational on their installation costs and the cost of the heat pump and cost of all the kit around it, that might come down to 9. Okay, take 3 off because you would spend that anyway on a gas boiler. Okay, 6 kind of marries up with a gas boiler then. So we'll see. I mean, it was meant to be announced the results of the white paper in May, but obviously COVID and everything else, it's been delayed again. So we don't know what it's going to be. What we can tell from this is it's going to be an upfront grant. So in a way, that's better than getting money over time because it's giving you a deposit on what you need to do. It's going to favour air source over ground source because air source is cheaper, and if it's a flat rate, it's really for the domestic market, not the commercial market. It's capping out at 45 anyway. But if you're only getting £4,000 towards an install, it's not really going to help greatly, even on a slightly larger system, 20, 30 kilowatt system. But you might see some installs at like small libraries or small civic centres, things like that. So we're going to find money from elsewhere to make the economics work, and there are additional income research going on, and there are changes, right? So, Crew, we're doing some research at the moment on heat shifting. So, people have been putting batteries in the house with solar PV, and lots of you might understand that, so that you don't use at peak periods, and you can use at cheaper periods. And there's time of use tariffs. So I don't know how many people know what time of use tariffs are, but essentially it says, either given any half hour or given any time period, like mornings, lunchtimes, evenings, post 7 o'clock onwards, they're different rates. Overnight's a different rate again. And you get cheap rates overnight, you get higher rates in the morning, you get really peaky rates at 4 till 7. If you can avoid that 4 till 7 on something like Octopus's Agile tariff, you're only paying about 8p. So again, that improves the economics. So we're looking at that and how we can use, say, an extra hot water tank to shift 3 hours of heat. We know that the National Grid and the district network operators will start to come up with demand response for heat pumps because they're going to be so big. Just things like frequency, just turning on your fan coil to defrosting coil will be enough to kind of balance the frequency of the grid. It may be that it's a really windy day, so National Grid says, can you please heat up your hot water now, please, for half an hour? Yeah, we can. Okay, we'll do that. And they give you cheap electricity, or they pay you to do that. So we'll see income streams starting to come on over the next year or two that will support heat pumps and how we can shift away from that peak period. Obviously, if we get rid of gas, we start saving other income streams as well. So you've got gas standing charge. Now, you're not going to pay that gas standing charge just to have a gas hob, right? So you'll probably end up putting an induction hob into your home. Gas goes from your house completely. That's really, really important because it means that you save £90 or somewhere between £75 and £100 a year. The average, I think, is about 90 on standing charges. A lot of us also have a contract with British Gas or whoever it is, HeatServe, or at £10 a month for looking after your boiler. again, that can go into your analysis of how much money you're saving over time. Because remember, heat pumps don't need a lot of analysis. You might say, yeah, I'll pay £40 someone remotely monitor it. They're just going to have a spreadsheet running in the background that says an alert, there's something wrong. Heat pump manufacturers will give you 7 years warranty, and many of them will give you 7 years labor as well, because they don't think anything's going to go wrong with the heat pumps in the first 7 years. So there's a factor. Something else I haven't put on this slide that I've just thought about is, in 2020, the Chancellor mentioned the fact that climate change levy, which is a tax on, there's been a tax on electricity to pay for climate change things like renewable heat incentive, the feed-in tariff previously, has always been dumped onto that because they've considered gas cleaner. As the grid is decarbonised, it's now that the grid is cleaner than gas. So from 2022, climate change levy is going to go on to gas instead. So if, say, gas prices were increasing at 2%, they're going to increase around about 4.5% going forward. So we're going to start seeing a balancing up of that unfair system. And what we want to see happening is actually some of the old climate change levy that's been sitting on electricity being dumped onto gas, because we're going to see the grid get cleaner and cleaner. By 2030, it's assumed that the electricity will be around 100 grams per kilowatt hour. It's currently around about 180, 200, and gas is 187. But when you take into the efficiency of your heat pump, gas is jumping up to, of your boiler, gas is jumping up to around about 222 grams, right? So that's another factor, that you're going to get compounding on gas pricing faster than you are on electricity pricing potentially over the next few years because of that switch in the climate change levy. So let's talk about running costs, because that was, I think, the second biggest point for lots of people. So what I've done here, I've made 3 assumptions. One is 15,000 kilowatt hours, which is what Ofgem says is the average household. I've taken from UK Power's website the average gas price that people pay and the average electricity. Now, some of you will have a cheaper gas price at the moment, I think because of COVID, and we saw negative oil prices that dragged down gas prices, and some of you were lucky enough to lock in a cheap price. That's gone. Next year it'll be back to where it was before. It's just the reality of the flex of it all, really. So they're standard. And then the one assumption I've made is the heat pump efficiency, and I've given 2 levels, 350 and 325. A good solid heat pump will be, like, a high quality one's 350. Some of the cheaper ones are probably around about 325% efficient at this 7 degrees. And living in the southeast of England, living in London, that's a probably fair assumption. I did a bit of research for this morning, and I thought, well, what's the worst month I can remember forever? And that was probably February this year. So I looked at what the average temperature for February was, with all the snow and ice and all those days that seemed to never get above 0, and it came out at 6.2 degrees. So even in our sort of worst memories, London doesn't really ever get that cold. So if we look at those, and then we look at the running costs, so a heat pump, a gas boiler is going to be around about 85% efficient. And you might say, I've got a condensing boiler. But I challenge you to say that you're probably running at 75 degrees and it's not condensing. You need to run it around about 60 degrees, 63 degrees for it to come back at 50, so it can actually be in its eco cycle. So you're probably, even 85 might be over egging it. But anyway, we'll use that number, which means actually you need more energy to match this 15,000 kilowatt hour heat demand in effect. So you need 17,647. Meanwhile, because the heat pumps are uber efficient, you need less. But obviously, it's a higher price commodity. So then what we do is take that 17,647, times it by the gas price, and then take the 4,285 and times it by the electricity price. And what you can see is actually, even at 325, it's kind of washing its face against gas on a running cost. Now, take £90 off of that because you're no longer paying your gas running costs. Maybe take £120 off because you're not maintaining a gas boiler British Gas anymore. And actually, heat pumps come quite compelling. So we are now at these points where the efficiency of heat pumps have got to a level that they compete on a day-to-day running cost with gas pretty comfortably. Now, we'll all find examples, right, of someone paying 2.8p off for gas and they're paying 16p for electricity, and this changes. Equally, on our install, on our projects, the guys were paying 6.6 pence for gas and they were paying 14 for electricity. I mean, and they were locked in for 5 years. I mean, it's a ludicrous contract they were on, but it made it very easy to install a heat pump for them because they were saving £1,000 a year without even thinking about it. So anyway, running costs, I hope that was clear. Planning is fairly easy on a domestic basis, right? There's sort of one rule is you've got to be 1 metre away from curtilage. So that's your boundary to your neighbour. Not always easy in London in terraced housing when either side is 5 metres. So you pretty much got to stick your heat pump in the middle of your house, really. Conservation areas, similar rules to solar PV. We've talked to London Borough of Wandsworth, and they said, as long as we can't see them, as long as they're in the back garden, we're kind of cool with them. Listed buildings, more or less the same, but they said maybe you should check if you're in a listed building. Commercial heat pumps, odd rule, but if you've got one heat pump, you don't need planning permission. You have a cascade of heat pumps, you need planning permission. We were charged £490, which I think is scandalous, considering this project will save the borough 17 tonnes of carbon a year and cut 120 kilowatt hours of gas flow emissions from air quality problems. How the council are not working this out yet, that actually they've got to massively incentivise this every way they can, it is beyond me. But what we found with Wandsworth, and Wandsworth is, I'm not digging them out at all here, I think it'll be across the country. They don't really have a policy yet for heat pumps, and they didn't even know the price. They had to go and look away and compare it with something else. And well, it's a bit like a solar PV system. We'll charge you this. They're not ready for this massive 600,000 heat pumps a year at the moment. They really aren't. So you'll have to do a bit of hand holding with them as much as they will with you if you did need to go for planning on a commercial project. The considerations came out. They weren't really that worried about the site of it because it was on a roof, but they worried about noise. And even then they said, well, put it in, and worst case scenario, you might have to do a bit of dampening against the fence or something. Our view, it's all probably going to be fine. So planning is relatively straightforward. I think what's more problematic is placement of your heat pump, particularly if you're living in London and you're constrained for space in a terraced house. If you're living out in Newbury, I keep mentioning our chap from Newbury, but you might have a bigger back garden, you can kind of hide it and things like that. Remember the rule, 1 metre curtilage, 1 metre from the border. So that's consideration. When you're installing it, the closer you put this to the original pipework, the cheaper it will be and less problems you're likely to have going forward, right? So if you can consider that's great. Where could you put them? Well, they could go at the front of your house, potentially, particularly if you have a reasonably nice looking unit. They could go in your back garden somewhere. They could go to the walls of the back of the garden, and you could have a channel put in, insulated pipe running back to your house. So it's somewhere at the back behind a tree or something that you don't really see it, hear it, whatever. But remember, it's still got to be 1 metre away from your fence. Or you could put it on your flat roof. Lots of people in London have gone out and built extensions in their kitchens. And this is a good example, this photo here. So you put them on rubber chocks so you don't get any vibration noises. It's probably going to be 2 meters away if you put it in the middle of your house from either boundary. So they're going to hear is London background noise. They're not going to hear anything. You're not really going to hear a lot in your bedroom because if it's cold, your window's shut. And yeah, placement, it's difficult. It is a factor and it's something you need to think about. And I think that's why some people will move towards the split system because they won't mind having that little bit of objet d'art in their garden. But they might not want something that looks like this picture, which is pretty bloody ugly, we have to say. So placement. One other thing, a product we've been working with commercially to date is a product called Hydromix. And it's a heat transfer technology. And you basically replace water and glycol in your heating system, in your radiators, with this product. And it's a nanotechnology, and it's not unsurprising that in the 21st century, someone's invented something. There's a better heat transfer than water, and this product is it. So it picks up heat much faster over the heat exchanger on your boiler. It will move heat faster from your heat pump to where it needs to be, and it has other factors as well. I mean, it's really good at stopping any calcification, any sludging. So if you flush your system out, you put this product in. It's a good time to do it when you're looking at a heat pump or a new boiler because you're going to flush your system out anyway. So that cost is already sunk. And then you're just putting Hydromix in. It's a really good product. And the reason I like it for heat pumps is it takes more heat from the heat pumps. The heat pump's working more efficiently, which is what we want it to do. It's also getting more heat into the rooms. And essentially, it beefs up the radiators by, say, around about 30% is the impact it's having, because it's creating more radiant heat than convective heat. So radiant heat is a bit like sun on your back. Convective heat, we all know, you see the cycles going up to the ceiling and then it cools down and comes back down again. Radiant heat's better because it gets into brickwork, it gets into furniture, and they hold heat more than if you just heat the air. So it's a really interesting product for heat pumps because we run at a lower flow temperature. So your boiler's running at 75 degrees. Heat pumps will run at 55. This is kind of important, right? So when you're having a heat pump assessment for a heat pump, you'll have to have heat loss calcs. They'll work out how much heat each room needs, how much your building loses, and therefore the size of the heat pump that you will need, but also the size of radiator you need in each room. Typically, lots of rooms in the UK tend to have oversized radiators anyway. You have like a 2 kilowatt radiator when you only need maybe 1.5 kilowatts. So the heat pump can kind of cope with that. But sometimes you might have to take a single radiator to a double radiator or a double to a treble. What Hydromix can do is kind of do that in effect, because it can deliver more heat more efficiently, more quickly. So like there was a trial down in Wales in social housing where this product managed to heat the house up in 9 minutes rather than 22 minutes, I think it was, in the standard system. So I think it's a really interesting thing. Samsung have just done a trial. We're waiting for the documentation in Korea, and they had 22% efficiency savings on their heat pumps with Hydromix in their system. So that's that one. And that's me, really. Just want to say a few up-and-coming events we've got. We are launching a green lifestyle home audit. We're calling it Cruise Home Carbon Audit. And we'll be looking at sort of energy efficiency technologies like smart radiator valves, smart thermostats, LED lighting, heat pumps, solar PV. They're the main products. And we'll give you paybacks and things like that. If you need heat loss calcs and EPCs, because you are going down that route of heat pumps, we can kind of provide that service for you as part of the audit. There is stuff about lifestyle, so your diet, travel, reduce, reuse, recycle. It's all kind of in there. So it's something we're launching. There's going to be a presentation on it. Again, it's all on the Eventbrite pages. So if you are interested in that, come along and see what we're offering and see if it would work for you. The next day, we are doing the second part of this, because this is meant to be for community energy, but a much broader audience came. So we kind of made it a little bit more about domestic than commercial. This one will be much more about commercial and how community energy can get involved in renewable heat projects in civic centres, with local residents, and also in blocks of flats. And then the third one is, again, more commercial based, and it's heating control. So zoning heating in schools, in libraries, in civic centres, and in commercial buildings. So if you're around any of those dates and you have a commercial bent to you for the second two, great. If you're interested as a resident in the first one, please sign up on Eventbrite. Thank you very much for your time.
Thank you.
Well, thank you, Toby. I hope everybody had their somatogen, Lucozade, Weetabix, various other brand named products that allegedly help our cerebral processes for that big information blast from Mr. Costin there. I've put in the chat some links to the events that Toby's just mentioned. So the first one to Kirsten is obviously open to anyone else about our home carbon audit, we're calling it. And the other two links, there's one for the building management controls and the second part of this more heat pumps for community energy groups and anything that is basically non-domestic there as well. Thank you, AM. So if I'm going to go through a couple of questions for you, Toby, now. So you're not let off the hook quite yet, but if there's anybody that's got a burning desire to ask a specific question question verbally, please use the hand sign now to raise your hand, and I can bring you in to ask your question directly to Toby, while I just condense a couple of the questions together to put to Toby after this. So Peter Wimborne has got a question, so please come in, Peter.
Can you hear me?
Yes, Peter.
Yeah. Toby, thank you ever so much for that. By the way, can I just say I'm pleased to see Rob Hughes here, because we've been talking about this anyway. So, hi, Rob. Talk later. I think we have the same question, and maybe Rob will sort of put it much more professionally. It's really to do with the installation of heat pumps in houses such as mine, which is a London terraced house, solid brick walls, no underfloor insulation. Now, when I've looked at what appeared to be the requirements, before you can actually install a heat pump, it's included things like underfloor insulation, improved loft insulation, and where possible, additional exterior or interior wall insulation. And the first two of those I could probably do. The third one, I'm not sure about. You mentioned it very briefly. Yeah, I mean, from what you're saying, the efficiency of these things is getting to a point where perhaps it's not so crucial. But
yeah, it's an interesting debate. I mean, I've tried in this presentation to avoid the fabric first conversation, because I feel it's another reason that heat pumps are getting stifled. We are looking at 50-year paybacks for a house like yours or mine to install exterior wall insulation. We've also got lovely brick houses that no one wants to whitewash staccato. So there's lots of resistance to that. That would cost, say, maybe £8,000-10,000. It'll save you maybe £150-200 a year. It is not a great investment, and we need the government to step up and make those measures. In terms of the other things like loft insulation, it's only cost you a few £100s. If you do your EPC, there will be confirmed recommendations that you have to take out. So if you don't have, it's now 275 mil, but I think if you had 250 mil, your EPC assessor will probably say that's fine. So those kind of measures that are relatively low cost, I would recommend doing. If you've got decent windows, if you've got double glazed windows, you're probably okay. And there's a feeling at the moment that actually, or a thought process at the moment that actually running long and low is fine. Run at 55 degrees, run your system, don't turn it off, turn it on, don't let your building cool down and then heat up again. And one of our members is a heating engineer, and he's been slowly turning down his gas boiler, or biomass boiler, I think he has actually, year on year, trying to keep his comfort levels the same, but just run it lower and longer. And slowly but surely, it's working, and his bills are coming down each year. And they're not noticing a difference in comfort. So I think it's just finding that point where, yes, you're still comfortable, the heating works fine, you're running at 55 degrees, and it works. And the whole point of a heat loss calc, which will cost you anywhere between 150 and 300 pounds, really, is to tell you what you would need to do. It gives that recommendation, say, look, if you keep the house like this, this is what you need to do. If you were to put in loft insulation on the floor heating, this is what you would need to do, and this is a side heat pump you would need. So it gets back to those running costs, but I can't help feel, when I look at the numbers here, and I know the 3.8 against the 14.27 can be debated, but they are apparently national averages, that taken from the site. At that level, if I'm clawing back £90 a year from gas standing charge, and maybe 120 a year from having to maintain my gas boiler with British Gas, I've kind of got another £200 to play with anyway, because I'm cheaper on a day-to-day running as we are now. So even if I did have to run it a little longer and harder in the deep midwinter, it's only 10, 15 days that I have to do that. I can afford to do it. So I think there is that thought process you need to go through. And I think you need to do kind of what I did in that presentation, is look at your income streams and say, this is what it's costing now. This is what it's going to cost. Okay, let's say I have to run it 20% more. What does that do to my running costs? Okay, but I'm clawing back this. I'm clawing back this. I've got to pay for a halogen induction hob. So let me put that cost in there as well. and then run a little spreadsheet on it and say, okay, this is where I come out. You know, I'm coming out this number. It looks pretty decent. I've done some research that I haven't put out because I want someone else to verify numbers for me on our gas flow emissions and what the social cost of that is. And it looks to me like it's around about £25 per kilowatt hour on NOx and carbon, NOx and particulate matter. I've not got a number for carbon monoxide yet, so it might bump up a little bit. But that is how the government says, can't remember the numbers now, but I think particulate matter 2.5 is £67,000 per tonne. And NOx are £9,000 a tonne, I think it is. Working at how much? Sorry?
I just need to say for those the people that have to leave at 7:30, sorry to disrupt you mid-flow, Toby, but just to say we understand if people have to jump off now.
Yeah, sorry. But I think people need to start considering those factors. And then that carbon saving. Let's say you save 2 tonnes of carbon a year. You know, companies like Saint-Gobain, the big French industrialists, have decided to say, right, every tonne we produce, we're going to say that's €50, right? So call that £40. And they've set up a fund, they're putting that money in. I think we have to start doing that as well and say, well, what is the social cost then of that carbon on us? So, okay, that's another £80 I'm actually saving in the social cost of the impact I'm having running my gas boiler compared with a heat pump. And I think over time, we will get to that point where we'll say, okay, between the gas flue and this, we're probably looking at about £100 of damage a year we're doing that we're not being charged for. And we should charge that upon ourselves. So I think that can go into your calculator as well, particularly if you're already making money on your heat pump compared with your gas boiler. So, yeah, sorry, I rambled on, but I think they're important points to think about.
Thank you very much. Thanks.
Okay.
Thanks, Toby. Hugh had his hand up next.
Hugh, you're on mute, I'm afraid. There we go.
Can you hear me?
Yeah, perfect.
Thank you very much indeed, Toby, for explaining in detail lots of interesting points. Initially, I was skeptical about the cost differential between gas and electricity. You're bang on with your prices. Naturally, I was concerned that almost 5 times more expensive for electricity than gas. But of course, after explaining that the efficiency of the boiler was going to be something like 350, 325%, then it starts to even out.
Yeah.
I don't want to go in great detail, but I think my principal question was, and this is the monoblock style of heat exchanger, can the monoblock system run horizontally on a flat roof, or does it need to stand vertically?
It needs to stand vertically. Yeah.
I see. Why is that? For free flow then of air?
The free flow there, yeah, it's all structured that way. So it's sucking air in from the front, some suck from the top, but that's the design of it, and it's that flow, and then it's the release afterwards. Because what the potential you have, and like one of the other questions that's bound to come up is, can I box this in? If you kind of produce that fan and put it on the ground, it would then be pumping cold air down, and we know what cold air does. It doesn't rise; it just sits.
Yeah.
So you would start to build a microclimate around your heat pump of cold air, and it'll just be sucking on itself,
okay,
which would damage efficiencies.
Yep.
I'm also concerned about these lovely boxes that we see, because I'm worried that you're not getting enough airflow around the heat pump to get the cold air away. So putting on a roof, and you've got to remember these things need to be, forget planning regs, they need to be 0.5 meter away from your wall, so there's plenty of air circulation.
Yeah. Okay.
And you'll see they're always on chocks. There's airflow underneath as well. They're important factors.
Okay. So I have a flat roof. Ideally, I could mount it up there. It would minimize the noise factor, and it would allow then efficiency of the throughput of air. What about pipe? What about pipe diameters? Are we speaking about 15 or 22 here?
22.
Okay.
Yeah.
So it's really just like an average domestic central heating boiler.
Yeah, I mean that's the concept, isn't it? You're trying to go like for like. You know, there is an argument at the moment to go bivalence. You know, where you kind of leave your gas boiler in, you put this heat pump in, you can connect it quicker, your heating system's down for less, and your heat pump does most of the heavy lifting. But when it gets really, really cold, your gas boiler kicks in. I don't like the idea of bivalency because you've still got gas flow. You're paying for 2 standing charges when you don't need to, all those kinds of things. But, you know, it is a potential way forward. And it's a potential way of driving the price down as well. Yeah,
actually, I like the sound of that combination because I have a Valent, fairly new gas boiler in a conversion, as the previous gentleman said, in a Victorian end terrace property in southwest London, a fully insulated underfloor heating system, loft insulation. We put in some 50mm wall insulation as well internally. So the house is pretty efficient, but it's still a costly business to heat.
Yeah, but what that might allow you to do, the measure you've made, is maybe run your system at 45 in a terrace house rather than 55.
Yeah.
And we saw on that chart before, I can't remember what the number is, but 3.6 up to about 4.06, I think it was. You know, so you're going to get that extra lift. And that has 2 impacts, right? Your day-to-day running costs are cheaper, but you're also going to get more RHI if you do that this year. You know, you're going to get, you know, that 0.4% extra pickup in what you're doing, because you're for every kilowatt coming in, you're producing more kilowatts out.
Yeah,
that ratio is increasing.
Okay, and just one last question, if you don't mind, Toby. Having constructed a few dwelling houses from new and conversions, installing gas central heating systems, installing underfloor wet underfloor heating systems, insulation systems, I mean, is it fairly straightforward on a DIY basis to install a heat pump on a roof?
Well, you have to be MCS accredited to receive the RHI, right? So, and they're not straightforward. I mean, you hear of enough problems from installers who have installed 20, 30 things that no, you should never try and do this yourself.
So to capitalize on the grant, then I must go down the accreditation.
Yeah, the subsidy rather than the grant, because it's subsidy over time. But yeah, you need MCS accredited. So you can go on the MCS site, put your postcode in, it will come up with installers. We've got a couple of installers we work with. So if you need advice from us, we can do that. Obviously, we can help you with heat loss calcs. We can help you with the EPC side of things. We're not doing installs ourselves at the moment. Certainly not on a domestic level. We tend to get involved in the commercial stuff because we raise funds for civic centres and things like that. So we get involved in the whole process of it rather than just the install.
Okay, I think I'd like to take you up.
And when Toby says commercial, he means non-domestic.
Yep.
On your offer for advice.
Okay, I'll forward this presentation to everybody. Yeah, I'll forward the presentation to everybody, so you'll have my contact details. So just drop us a note, and we can help out. You're most welcome.
Okay.
So Cara was asking about. Sorry, I was just picking up on it because it's a nice segue actually. Thoughts on Cara Sloan? Thoughts on hybrid heat pumps? I mean, there's 2 things here, right? There's bivalent systems, which is you've already got a gas boiler in and you kind of slide this alongside and it does 80% of the heating. You can have a slightly smaller heat pump. What happens after your gas boiler dies is my question there. Then the hybrid system is it's actually all in one. You've got a new tiny little heat boiler plus your heat pump. I don't like them. I mean, I don't see the point. I think we should be making this drive towards getting rid of gas completely. And I think the IEA announcement, you know, the industry has been looking at hybrid systems and bivalent systems for the last 2 years. And I was slowly getting persuaded. I thought, no, I don't think this is right. And the IEA, I think, really highlights the point that we just have to get gas out of the system. If we want to hit 0 carbon by 2050, if not earlier, this is a massive part of it. It just needs to go. So my preference is for not.
Okay, thank you. I'd like to bring in Sarah Nairn now with a question, waiting patiently, and thank you for waving there, Sarah. Go ahead.
That's Sarah, actually. Hello, thank you so much for that. It's fascinating. I had a bit of a job to keep up because I'm not techie at all. In fact, oh, sorry about that. My question is, I can't quite picture what you mean, what it looks like when you say a split system. I was sort of scribbling on the notes that were on the slide, and it seems that the monoblock has got a water tank and buffer, which I don't know what the buffer is, and then the other one's got a compressor as well. So is it possible to show me or explain to me what bits are inside and what bits are outside with the split pump, what it looks like, what space it takes up?
Yeah, I can. So you remember the picture of the very sexy looking red unit?
Oh, yes.
Yeah, that is a split system. So all you've got outside is the fan. Inside, what you'll have is a hot water tank like you might have currently. But it's in a square block rather than a circular system, and that's because you've got the compressor built into it and you have a buffer tank. Why do you have a buffer tank? It's because sometimes you might be the only person at home, you've turned off all the radiators, or you've got smart radio valves, everything's turned off apart from your office. And that tiny little radiator in your office is not enough of a draw for the heat pump to turn on. So what the buffer does is says, I need heat, give me heat, give me heat. So that when you call for it, there's 30, 40 litres, just a tiny amount, to provide heat to you. And then the heat pump says, okay, you're asking me to wake up now, I can now come back on. So sometimes you might not have enough demand in your house. So that's what the buffer does. So what you end up with is a bit of a fridge freezer type in that system. And it might be 2.4 meters high, 600-700 wide system. If you're talking about sort of 200 litre tank, you're looking at sort of diameter of about 500-600 and around about 1.8 high. So that's the difference you're talking about, really. It's about half a meter to 3/4 meter, slightly bigger. It might be slightly wider with the split system. It's not much bigger. You know, if you've got a cupboard, it's just going to fill the cupboard a bit more than maybe just a hot water tank will.
Okay. I didn't realise the red box was the split system.
Yeah. So that is because it's just a fan. So if you look at the picture, you can see a little dome. That's the fan there.
Yes.
Whereas when you look at the valent system, you can see the fan actually in the black mesh.
Okay. Oh, that's helpful. Thank you so much.
Okay. There's a few questions on here. Patrick's talking about microwave boilers. I mean, Patrick, microwave boilers are really cool because they heat things super fast and all that kind of stuff. But you can't get over the fact that it's one-to-one heating. So for every kilowatt you're putting in, you're getting 1 kilowatt out. So your running costs are going to be 14 point whatever pence we decided was the national average, 14.37 pence. You're not getting that. You're not taking power from somewhere else to create. You're putting 1 kilowatt in to get 1 kilowatt out. So they might be relatively low cost to install, but they're not going to compete with gas on a day-to-day running basis.
Yep, thanks. It sounds like they're very much at the prototype stage at the moment anyway as well. So I'd imagine there'd be some teething issues probably for a couple of years still. Yeah,
and they're similar things. There are infrared boilers, which superheat super fast because you can get so much power into infrared. But again, it's one-to-one heating. So it's that day-to-day running cost is always going to kill those ideas.
Thanks.
Okay, I'll just pull in a couple of questions from the earlier parts of the chat, if you don't mind, Toby.
Yep.
So, question from Fritjof: how to reach high enough temperatures to interface with the existing central heating system and provide hot water at 60 degrees?
Sorry, say that again. So how to integrate with the current system?
Yeah, how to reach high enough temperatures to interface with the existing central heating system and provide hot water at 60.
I think I may have covered this already. So what you will have is actually you'll heat the water up to 55 degrees, and every so often it'll go to 58, 59, whatever it needs to do for Legionellas. And it'll do that once a week. right? So it's a very low, and it'll pick a time of day. It'll do it at lunchtime when it's sunniest, and so it's trying to kind of, there's no AI here, but it's just saying law of averages. I'll do it at this period because overall that's probably the best time of day to do it. So you'll get that temperature up to the hot water you need, 50, 55. Your flow system in your radiators will be lower than it is today, right? That's what we're talking about. So you will need slightly bigger radiators, maybe in some rooms. Talking to some of the bigger installers, and I was talking to ISO Energy, they're quite expensive, but they're really good guys, and they know their stuff really well. And they've said domestically, what they tend to do is put a heat pump in and just say, see how you get on, and we can come back and upgrade radiators if you need them. And they said, very, very rarely do people phone us back, because what they're doing is they're looking and saying, well, you kind of got 2 kilowatts in here already. It's not that big a room. I think you're going to be fine. So it's looking at those kind of assessments. Things like Hydromix will make a difference, right? That's a really, really good product. Whether you go for heat pumps or you stick with your gas boiler, it's a really good product because of what it does. It brings more heat into the room. Because it can take more heat off of the boiler or off of the heat pump. It gets there faster. It heats it up faster. It's essentially chunk up those rads. We're thinking that you might not have to make any changes with Hydromix. We haven't got the science behind that yet, but just anecdotally, the first thing you do when you put Hydromix in the system is turn down all the TRVs because you know they're not going to need to be at 4 anymore. They only need to be at 2 because the amount of heat is pumping out. So there's ways and means. I think about my system here, and in our lounge we've got one of those sort of bent radiators around the bay window, and it's normally set to 2 or 3. I mean, it's only on 2 or 3 days a year that I would crank it up to 5. So it's that balance you're deciding on. Do you want to go for a bigger system, more costs for a couple of days a year, or do you say, actually, when those few days in London it gets that cold, I'll just put a blanket over me? I think we kind of got to start making those assessments, because it's not many days. When we look at commercial buildings where you've got the ability to have 3, 4, 5, 6 heat pumps, we're constantly coming to the conclusion, stick with the brand new gas boiler that's there, rather than putting in six heat pumps. We're putting in 4 heat pumps. They'll do 80% of the heating at 55, 60% of the cost. It's a good number. It kind of works. And what we think is that 80% in London, because these numbers are all based on the national average, right? The system is nationally. So you're including, Scotland in that and everything. London never gets cold. So, how many days is it going to be that actually the gas boiler kicks in? And we're really interested in monitoring that on our first project. How much gas is actually going to be used over a normal winter? And we think it's going to be lower than we're predicting, because it's not national. There's another factor here, right? Is that we're working on 20-year average temperatures. We all know that climate change has accelerated quite rapidly over the last 10 years. And it's getting warmer and warmer and warmer, and it's compounding on itself. So taking a 20-year average of what's going to happen over the next 10 years is probably not the right guess, right? It's going to be a quarter degree, half a degree warmer than that on average. So that's going to play into these numbers as well. So there's lots of factors there to think about, but I do think part of this is we need to do the right thing. And if it's for 2 or 3 days a year that it's all right, it is blooming cold in here, it's probably manageable by having a system that is sized to do 99% of your heating. There's a question here. Please, can you explain whether existing pipes and radiators can be used? Yeah, right. So I think Hugh was asking about the millimeters of pipes. Yeah, we're talking about sort of standard 22 bore piping. The radiators, most of them will definitely work. You may need in 1 or 2 of your living spaces, your kitchen, diner, or your lounge, you may need to go from a double to a treble, or from a single to a double. That may be the extra boost you need, but typically a lot of this will be fine. You won't have to upgrade too much at all.
Okay, some questions from the earlier session. John Mullen says, I want to make it happen quite quickly, having researched it. How can I make it happen ASAP?
Yeah, there's the thing, right? I think I touched upon this. There are very few installers. So when we started this, Crew won a grant to develop the next generation of community models around renewable heat. We won £100,000 to develop projects in civic centres, in communal heating, and this project domestically. And I did some research by going to the lead generators. So when heat pump people or anybody is looking for leads, they go to these companies. The two top ones in the UK, one had no installers in London, the other one had 6. When I checked it, 4 of them weren't NCS accredited. So there were only 2 heat pump installers. And when I phoned them, only one of them phoned me back. So that is one of your constraints, finding installers who are prepared to do installs. Then what you need to do is EPCs, heat loss calcs. So you need to get someone in to do those. Then you're going to have lead time with the heat pump installers. So you need to factor that in, that they might be able to help you for the next 6 weeks, 2 months. They've got huge lead time. Kit is tight at the moment because of COVID, because of Brexit, because of we're just going through a closed window on the commercial side. So there's lots of factors there. I mean, there's a really good presentation which I can send a link to in this, where a UCL professor installed a heat pump. And he did this fantastic little map of his days, like the first day he thought about heat pump, and from start to finish. And his was it very much COVID impacted. I think it's about like 6 months he spent. Now, my view is it will probably take you 2 months, maybe 3 months in the entire process, because that's just what it takes at the moment. We are very, very tight on installers. So yeah, build that in. Start now and say, I want this. We can probably recommend an installer or 2 to you, and then go and find another one. Get 3 quotes.
3. Yeah.
Get yourself 3 quotes.
We had a question from Peter about the environmental impact of refrigerants and how we can kind of square the circle of that, being environmentally conscious, I guess, was the gist of that one.
Yeah. I think we're getting ever and ever. I should have done a chart on this actually, but there was so much in there already. I didn't want to overwhelm people with some of the real technical stuff. But if you look at the new valent system that we were pictured there, they're using propane, and its global emissions are like down at about 4 now, and I think the original refrigerants were like 790 or something. So I mean, we've come off dramatically. The other thing about some of these eco refrigerants is it's really helping them boost their efficiencies as well. So I think it's less of an issue. It's probably a non-issue now compared with where we were 2-3 years ago, when we were looking at having a global, global carbon something, GCC is it, or GCF, global carbon factor, of like 500. We're not. We're down into low figures now.
Yeah, there was also a question about the RHI and whether it's means tested or not, and that sort of thing.
No, it isn't. It is just first come, first served. There are degradations. If you hit a certain number of installs, it will drop. I think it's 10% on this one. Interesting enough, they've been ramping up the air source heat pump one because no one's installing air source heat pumps at the moment. So it's gone up from about 10.234 to 10.92 at the moment. So there's plenty of headroom, would be my guess on that. You can track those numbers on the government's website if you have about a week and a half to follow various links. So no means testing. Some of the grants, like the Green Homes grant, if you were means tested, you could get 10,000 rather than 5,000. But obviously that's gone. It'd be great if that came back for heat pumps. But what's going to replace RHI looks a bit like Green Homes grant, really. But for now, no. You can claim whatever you need to. The other thing, sorry, a little top tip.
I was just going to say,
sorry, Alex. Go on.
I was just going to say, if you've already secured yourself the Green Homes grant, there was a question that comes up often about how that will work with RHI. So basically, you can get up to £5,000 from the Green Homes grant if you've already got that. And then you can basically get that will get that £5,000 will get taken off the kind of notional about sort of 10 to 12 grand you would get over the lifespan of the renewable heat incentive. So that would be a total of 10 grand's worth of subsidy if you've got the Green Homes grant. If
so
that makes sense.
Essentially, it's an advantage on the RHI, isn't it? Is a good way of thinking about it. So you're getting cash up front rather than over a period of time. But yes, you'll end up with the same amount of money over the 7-year period. It's just something that comes up front. Alex, sorry we keep cutting over each other, but your pitch is frozen, so I don't know when you're about to speak.
Oh, that's because I'm toggling backwards and forwards between the notes I'd pulled out of the chat to try and make it a bit more. I could whiz through them up and down better. So my apologies. It's not just because I'm in the middle of nowhere with a Wi-Fi signal that's dodgy. Okay. Last couple of questions, unless anyone's got a burning one they've come up with, pop your hand up or forever hold your peace, or just join us for our one of our next presentations. That I think there was a question a bit from Cara, Sophie, asking about internal space requirements, like bigger radiators, extra space for the around the pump and what have you. And I think you pretty much covered that. But
yeah, I mean, it depends whether you've got, you know, a combi boiler now where you don't have a hot water tank. You know, if that's the case, you're losing a cupboard. The other way about thinking about it is you're exchanging a cupboard, because obviously you're getting a gas boiler cupboard back because that can come out, but you need something to fit around about 180 meter high by about 600-ish round hot water tank.
Yeah. And there was a question on info on other countries where they've moved to heat pumps, Sweden, Norway, etc. What's their experience? So I noticed this week someone has announced they're going fully heat pump-tastic in a very short amount of time, and I can't remember what the year it was or what country it was. Maybe it was Germany. I'm making it up now. Did you see that? Do you know what I'm on about, Toby?
No, but the only thing I'd say is that we do have this massive adoption in much colder countries. I lived in Switzerland for 2 years, and you know, winters are proper winters out there, and you know, lots of people had heat pumps already back in 2006. So, and they weren't that efficient, you know, compared with what we have today. So the fact that people can make them work in much colder climates than ours, and you know, living in the southeast England, and particularly living in London, we've got a real microclimate. And again, when we're taking this sort of even 6 or 7 degrees, you know, they're going to be taken somewhere open like Heathrow Airport that's got a massive great tarmac that can chill down at night. You know, our back gardens are probably a degree or two warmer than that, because we've got the microclimate of all our houses chucking heat out into them. So, you know, I think there's factors there that I think it's a really good point that, you know, we've seen this happen across, you know, Scandinavia, Germany, Switzerland, and they have brutal winters. I know I've lived a couple of them.
Yeah, and it's kind of embarrassing that, you know, from my fuel poverty perspective, we have 3 times more cold-related excess winter deaths than they do in Scandinavian countries. So we really need to sort out our housing stock in terms of heating source and how thermally efficient they are. And I would just like to say thank you for your luck. You are the dedicated 14. That's what I'm going to call you. At the peak, we had 49. You have lasted till the end, you guys. We should have like a special certificate for, you know, we've reached 8 o'clock. It's a Monday night. I think you can all give yourself a round of applause just for being here, because you're obviously eco pioneers, that you're interested in this stuff now. And I'd like to thank you for Toby for putting his brain on this evening and sharing some of that with us. And we hope to, you know, Toby's contact details will be on the presentation slides, and we'll send links to this recording. We're on all the social medias. We have a brilliant newsletter that we send out periodically. Sign up and find out what else we're up to. And I just like to say we'll send out a 5-question feedback form for you, just to find out about what you'd find interesting and useful in future. So This was free, so please take the opportunity to just give us a bit of useful feedback so we can keep on doing this better and better, because you've been guinea pigs this evening. And just thank you again for all attending and giving up your own time. If you'd like a closing comment, Toby, go ahead.
I just want to ask, John Mullins come up with something I think is there a list of reputable installers? MCS has a list of installers that
I've done that all on the chat.
Yeah, they are all checked every so often. That still doesn't mean that they're the best. So I think it's a combination of looking at those, looking at Trustpilot, talking to us about, you know, the installers we've used in the past, getting into little forums, having chats. You know, I think you've kind of just got to build this, really. MCS is not the be-all and end-all. You know, they don't do enough checks to make sure everyone's really, really good. Because you need to be MCS accredited, really, to be an installer. So the fact that there's bad stories out there suggests that MCS aren't doing the best job in the world. So be aware of that. Do a bit more research. Look at Trustpilot and things like that too.
Yeah, and there's a good Facebook group for heat pumps for those of you that are super geeky. But if you're like me, somewhere middle of the road, we've got a service launching which will be helping people work out what best and what's going to give them their biggest bang for their buck in terms of carbon reduction for those of us that can afford to do this now, right through to the future webinars where if we get 10 of you saying, oh, we'd love to know more about this, and if we don't know, we know lots of people that will know, and we can arrange a webinar around any of your suggestions. So once again, thank you very much for coming along this evening, and you're all allowed to go and reward yourself with a delicious dinner if you haven't had your dinner this evening. And Toby, I hope you get a bloody good night's sleep tonight, because you've just like, well, my brain's lightly melted. I'll just leave it there.
Yeah. Okay. Well, guys, thanks everybody for coming. It's great to see so many people interested in heat pumps and, you know, concerned about the climate. So that is brilliant. So thanks for spending time with us. Good night all.
Thanks, Alex. Thanks, Toby.
Cheers. Bye.